Dear students, we already learned so many things about electromagnetic waves and properties and how it propagates through the medium or in a free space or in any conducting medium. So everything is expressed in various different forms. Now in this class, I just particularly focusing on how to express the electromagnetic wave that is propagating in any form in a phasor form. There are different way of expressing a function. So there may be various type of coordinate system we already discussed in the previous classes, and we particularly did many of the examples in Cartesian coordinate system, spherical coordinate system, and cylindrical coordinate system. And in the same way, here we are going to express the propagating waves in a phasor form. That is the focus of this class. Last class we studied about the wave equation. Wave equation is completely describing about the characteristics of wave which propagate in a conducting medium or through the free space. Let's write here the characteristic equation of the electromagnetic wave, how it propagates in a lossless medium, how it propagates in a free space. The expression is so here we neglected the second name. We neglect the second name because it is a lossless medium, so there is sigma is equal to 0. So now I just want to express the electromagnetic field E in terms of phasor functions. So better we stick on with the exponential function, which is can be used as to express in a phasor form. So e power j theta can be expressed as cos theta plus j sine theta. So this is the exponential form of representing a complex mathematical equation. So in a similar way, I can represent an exponential. In exponential way, I can represent the electromagnetic, the field E. So that E can be represented as E's vector can represent the magnitude of E J omega t. So the component of electrical field which contributed to the power which aid to propagate the field is the real part of the E. So the real part of the function, the complex function, is real part of E into j omega t. And if I substitute this the vector that is expressed in exponential function to the equation number 1, substitute 2 in equation number 1, the 1 tends to be the square real part of j omega t mu epsilon the square 30 square instead of E is real part. And now if I differentiate the right side function 2 times with reference to the times mu epsilon, E is a constant now here, that's the maximum value of the E field, but here I am differentiating e power j omega t with reference to t 2 times, so this becomes j omega e power j omega t into j omega into e power j omega t, so that it becomes real part of minus omega square e power j omega t. So if you take this function on the left hand side, this can be expressed again, expressed in another way. So you take the real part outside, because on the both side we have real part, and you take the divergence, the function, multiply it inside, plus 2 epsilon omega square e, and we can take it out e power j omega t complex exponential function, which is common on both both uh, both right hand side and left hand side. We can attribute it to 0. So this is nothing but we can take this function separately out, del square e plus omega square equal to 0. Now we are going to substitute this function mu epsilon omega square equal to beta. A new function we are introducing, so beta equal to mu epsilon omega square. Let us take this as equation number 3. By substituting the b in 3, the 3 becomes let us take this as b square, the b square, so this becomes 0. This is the wave equation for lossless medium in phasor form, and it is called Helmholtz equation. So vector Helmholtz equation. So the wave equation of electromagnetic field in the phasor form is vector Helmholtz equation. Now we are proceeding with the b square, which is a new term introduced. So b square is mu epsilon omega square. So beta becomes mu epsilon omega. Velocity of electromagnetic wave depends on the permeability and permittivity of the mediums. Here, mu and epsilon represent the medium and its constant, the permeability and permittivity of the medium. So the velocity can be expressed as root of mu epsilon. So the omega becomes beta divided by mu epsilon. So this becomes beta v. Hence, so the velocity of electromagnetic wave is v equal to omega by beta. Where beta is phase shift constant. Because when the electromagnetic wave propagates through a medium, at some point there is a shift in the phase. So this might happen because of the series attenuation. From the various kind of medium will degrade the phase shift. So this is a normal phenomenon. So beta indicates the phase shift constant. Now if we come to the equation number 3, let's take this as equation number 4. Let's take equation number 4. That's square e plus beta square e equal to 0. So we know that del square e is x prime phi square plus but E is oscillating along the x-axis, so there is no point of differentiating this function with reference to z and x, y and z. Now we can replace del square E as dou square ex by dou x square. So this becomes this is the phasor form of electromagnetic wave, and it is expressed in terms of E. So we have another electromagnetic wave equation which is in terms of H. If you bring it to the H terms here, we will get the same expression, but H is varying along the y-axis. So this becomes d square H y divided by dou y is square plus beta square H equal to 0. So both the equations are same. So both equations represent the phasor form of the wave propagating in free space.